like this. He used this method. He wrote the numbers 1, 2, 3 up to 50 like this in the ascending order. Then he wrote the numbers in the descending order. And then he took the sum of these two. Left hand side 2s, and we see 51 sum of these two, 51 sum of these second terms, 51. Now nth term is 0, therefore 0 equal to 64 minus 4n plus 4. Therefore 4n is equal to 68. From that, n equal to 68 by 4, 70. In this case, we are not to show the detailed steps of solving. We can solve on the right space of the sum concerned. Then there we write good morning. Welcome to btosacademy. Welcome to my maths class. Already I have started sequence series in the earlier episode. Today I shall continue AP, after that GP, arithmetic progression, after that geometric progression. Today I am going to start like this. Students who are interested in mathematics, let me tell you one story. In England, there was a boy who was reading in lower classes, 6th, 7th standard. He was a naughty boy in the classroom. Mathematics teacher couldn't restrict him, but the boy was very intelligent. One day, to control him, he gave one sum in the classroom and told the students to finish that sum. The sum was like this: to find the sum of the teacher thought that it is time taking. We take like this. After giving the sum, the teacher was busy, but one boy, that very boy who couldn't control himself, actually he was naughty, disturbing other students. When the teacher came to his table, after few minutes, the students ran to him and told that he has already solved the sum. The teacher was just astonished. The students had solved the sum. He solved. After that, he reported his mother that the boy will be a famous mathematician. Actually, the boy was Frederick Gauss. He will read about him in later classes, higher classes rather. He solved the sum. What did he do? Let me do that. He wrote these numbers in reverse order. then the sum of these two. One plus 50, 51. 2 plus 49, 51. 3 plus 48, 51. Now, how many 51s are there? This is 50th. Therefore, sum of these 50 number of 51s is 50 into 51. Therefore, A is equal to like this. He used this method. He wrote the numbers 1, 2, 3 up to 50 like this in the ascending order. Then he wrote the numbers in the descending order. And then he took the sum of these two. Left hand side 2s, and we see 51 sum of these two, 51 sum of these second terms, 51 sum of the third terms, 51 like this. The last one is also 51. This is 50th, 51. Therefore, sum of this is 50 into 51. Therefore, A is equal to this. This was the method. Now, we find these are in AP. 1, 2, 3, 50 are in AP. Here, first term is 1, common difference is 1. Now, if I get numbers which are in AP, how to get the sum of the numbers? That is the theory I am going to discuss. To find the sum of first in terms of an AP having first term A and common difference D. Let Sn equal to A plus D, A plus 2D. Then nth term already I have discussed in the earlier class. Now we write these terms in the reverse order. Here we can mention also Sn equal to like this. The last term is A. The method used by Gauss. Now, if we add, the left hand side will be A plus this one that will be 2a plus n minus 1 whole into d plus 2a plus n minus 1 into d plus dot dot dot. The last one is 2a plus n minus 1 whole into d. This is nth group. We find all sums of each column same, and each is 2a plus n minus 1 whole into d, and there are nth group. Therefore, sum will be n into within brackets 2a plus n minus 1 whole into d. Therefore, Sn is equal to n by 2 2a plus n minus 1 whole into d. This is the second formula. The formula for nth term, that is an or tn. Already I have derived that in the earlier episode. Now we have found the sum of first n terms of AP, a plus d, a plus 2d, dot dot dot. This is the sum. Now we can deduce from this result this one also. And already we have learned this is nth term, therefore we can write this as an plus a or a1. If we write the first term a1, here we have taken the first term a, first term a1, that means a is a1, then the formula is this. Now we have derived two formulae for nth term and for sum of first n numbers of AP. Now we work out few sums. I work out the first sum. Already written 3 sums on the board. For first term, which term of the AP is this? I start like this. Let nth term of 64, 60, 56 be 0. Now nth term an is equal to 64 plus n minus 1 into minus 4. Or you can write the formula first, a1 plus n minus 1 whole into d, then you put the value and you mention on the right side here a1 equal to 64, that is first term, d common difference is equal to, see, the numbers are decreasing, therefore common difference is minus 4. 60 minus 64 or 56 minus 60. Now nth term is 0, therefore 0 equal to 64 minus 4n plus 4. Therefore 4n is equal to 68. From that, n equal to 68 by 4, 70. Therefore 17th term of the given AP is 0. Answer. Number 2. Let AN is equal to 302. Here A1 is equal to 3, D equal to 8 minus 3, 5. Therefore A1 plus n minus 1 whole into D is equal to AN, putting value 3 plus n minus 1 into 5 is equal to 302, or n minus 1 whole into 5 is equal to 302 minus 3. Term 3, 8, 13, 18. Okay. 3 plus n minus 1, 5 is equal to this 302 minus 3. We find here the difference. Therefore, n minus 1 equal to 299 by 5, which is a fraction. Now, n is natural number or positive integer. Therefore, n minus 1 is also positive integer. But we find here n is fraction. Which implies n is fraction, but n is positive integer. Therefore, since n is positive integer, therefore it cannot be fraction or negative. Therefore, the answer will be 302 is not a term of the given AP. It was asked in the question whether 302 is a term, but after calculation we find n is fraction. Also, if you find n is negative, that is not possible. Therefore, 302 is not a term of the AP. Therefore, the second sum is solved. First sum is also solved. Now we move to solve sum number 3. For that, how many terms are there in the AP? This. Let there be in terms of the AP 10, 13, 16, 43. Therefore, 43 is the nth term of the AP. Therefore, 43 equal to A plus n minus 1 whole into D. We put value 10 plus n minus 1. Here difference is 10, 13, 16. Common difference is 3. Since D equal to 13 minus 10 equal to 3. From that, n minus 1 whole into 3 is equal to 43 minus 10, 33. Therefore, n minus 1 equal to 11. Therefore, n equal to 11 plus 1 equal to 12. Therefore, there are 12 terms in the AP. In the given AP, no need of writing repeatedly. There are 12 terms in the given AP. Therefore, the sum is solved. For sum, I read out and write down the information. The 5th and 13th terms of an AP are 5 and minus 3 respectively. Find the AP and obtain its 16th term. First, I write down the information in short form. Given T5 is equal to 5 and T13 is equal to minus 3. 5th term, 13th term, we have to find the AP. Let the first term A common difference D. Therefore, T5 is equal to A plus 4D, that is equal to 5. This is equation 1. T13 A plus 12D is equal to minus 3. This is equation 2. Now we solve for A and D. You can show the steps of solving, or you can solve on the right side of the sum as I am doing. A plus 12D minus 3, A plus 4D 5, subtracting minus A minus 8D is equal to minus 8, therefore D equal to minus 1. Now we put the value in any of the two equations. A minus 4 equal to 5, from that A equal to 9. In this case, we have not to show the detailed steps of solving. We can solve on the right space of the sum concerned. Then there we write solving A equal to 9, D equal to minus 1. Now in the first part, find the AP. Therefore, the required is first term 9, then decreasing 8, 7, 6, dot, dot, dot. In the next part, it is required to find the 16th term. Second part, T16. We use the formula A plus 16 minus 1 into D. T16 A plus n minus 1 whole into D. Now I put the value 9 plus 15. Here D is minus 1. 9 minus 15, that is equal to minus 6. Therefore, T16 is equal to minus 6. Some prefer to write A16, A1 first term, A2 second term, A3 third term, like this. They use the symbol A16. Therefore, this sum is finished.